Hello, everybody. Welcome to today's meeting, community meeting, this monthly meeting for March here in Kubewarden. And as usual, we have some people from the Kubewarden team. Today, I'm gonna be your host for the meeting. And yeah, maybe we can go directly with the agenda. Let me see. I'm gonna just share. I'm sharing. You should see the office hours, and you should see me around. We were joking that
Yes,
this is
we
kind of
could.
like a clippy situation. So it's weird because I should look to the other side. So then, no, it doesn't work. Okay, so you can see the agenda in the agenda today, which is a nice one. We have the upcoming 1.11 release, which has a lot of improvements. We have improvements for the audit scanner, performance improvements for the host calls in policies, and a new host capability, which is the OCI one. We also have some tidbits about KubeCon. We have an update of policy that is a new one, and that comes from community. We will talk more about it. Then some code coverage improvements, which is super nice. And then a little bit of yeah, a peek into 1.12, which would be in the future. Okay, so about the agenda. I suppose we can start now with 1.11. So in that sense, I wonder who's gonna take the topic.
Okay, so it's
Before
yeah.
Yep.
Sorry,
before
Flavio.
going into the topic, so we can also share that we are going to tag it next week. So 1.11 is currently release candidate 4. Everything is green, seems to be working well. We want just to take some extra days to make sure everything is working properly, and we will tag it next week. So it's coming. Sorry, Fabrizio, please go ahead.
Yeah, no, thanks for the clarification and the good news. So yeah, the first topic was about Audit Scanner. We had some feedback from users that it was causing a lot of memory consumption, and so we tried to see what can be done, and we also realized a better way to deal with the policy reports format. And yeah, I'm gonna just share some results without going into deep. And
Results are always interesting.
yes, so before this is a cluster which has 300 resources in a given namespace, the default namespace, and before we were having this memory consumption of 265 megabytes, and then it was taking 47 seconds to scan it. This is on my local machine. And then after the optimization, we reduced the memory consumption more than half, and then we are like 50% faster in processing the results. And also, I'm gonna show you the results, which sorry, I stopped. Well, yeah, I'm gonna talk about that. So this was the yeah the new improvements that we made, and so the memory consumption was basically based on the caused by the fact that we are getting a lot of resources from the cluster. So in case of like cluster with a lot of resources, we would just get like a really big list of all the resources being in a namespace or cluster-wide resources. And then we were processing them, which means we were sending calls to the policy server in audit mode. So in the audit endpoint, we are getting the results, and we were saving just one big report. And all of this caused two main problems. First of all, that without pagination, we're just getting like a limited list of resources, which caused the memory to increase, with the number of resources. And the second problem is like we were also accumulating all the results in a big report, and the report was growing with the number of resources, and it was kept on memory till we didn't save that. And then when we were saving the policy report, sometimes in certain situations when the report was too big, we were reaching the limits of etcd. So the max entry limit, we couldn't basically like save something which was over 3 megabytes, I think. There was
Yeah,
the
I
limit
think it's
set.
right.
Yeah. So then at the end, the whole thing wouldn't save the report, and that this was confusing. And so the first thing that we tackled was like introducing pagination while fetching the resources, and while solving another problem, because we were using a map data structure that was kind of like optimized to get to not repeat queries on the API server, but this also caused some memory consumption. So at the end, we decided like a trade-off, like using pagination, and for each resource going to see doing the filtering in the local, not using the server-side filtering of the object selectors, and then hitting the policy server for each resource, each policy, and then saving one result per resource instead of having this big namespace policy report. And this helps with two things. First of all, we reduce the memory consumption in the worst case, and also we have like a stable memory consumption, so it's predictable because we just like accumulate 100. 100 is an arbitrary number we choose for resources, but maybe in the future can be configured. And yeah, by doing this, it's constant, so you always have the same memory consumption. It's predictable, and also you have like policy reports which are based on resource, and which make things easier also to query. So a user can go and query a policy report based on the UID of the resource, and then get the results for the single resource without having to query and parse like a huge list of resources. Imagine like a cluster with 1,000 resources, and then you would have this huge report with a lot of results, and then having to parse it and then to filter it. So yeah, that was basically it.
I did see a spoiler of some flame graphs and things like that. Maybe, I mean, I
Yeah,
understand that.
I can share it. It's I didn't want to go too deep with the code, but we could
It's
in the
just, yeah, a bit of a spoiler because I think it's cool, to be honest. I mean, it's normal, no, profiling and things, but it's a
yes.
good.
So this is how we found the problem, so the issue, and we were looking at this. This is like the old version, the 1.10, and we realized that we had all this repeating pattern of having big flames related to the scan namespace, which was connected to get resources for policies, which were taking here like almost 40% of memory consumption in the heap. So the idea was instantly to investigate that. And and also this means that we were accumulating stuff in memory that we were not it was not garbage collected because of the report that we were building by scanning all the resources, so like just a big report. And here I think that it's called get resources now. You can see how yes, it's very small. It's like 0.4% of total memory consumption because it's paginated. And so yeah, this was quite easy to fix. Alongside this, we solved a lot of, you were talking about code coverage, Victor. So we increased a lot the code coverage. So we are like about over 70% of code coverage. We yeah, we fixed yeah, a lot of tests and also like clean up the code. So it was a
Yeah,
very
that's super
nice
nice also, no? I
yeah
mean, I
moment
think that's a
actually.
huge win, to be honest. Besides the
Yeah,
refactor, no, being able to
yeah.
ascertain the whole thing with the tests and so on, that's super nice.
Once we were there, we decided to clean the house. And let me see if I can show finally the policy report. So this is like how a new policy report looks like. So it's based on the UID. So the name is the UID of the resource. And let me I forgot.
Wait, yeah. Wait.
Here we go.
Perfect.
So this is how a new report is made. You have like this is a policy report because the resource is namespaced. So it lives inside the namespace of the resource which targets. And then we added owner references to the resource. So when a resource gets deleted, also this policy report gets deleted as well. There is some metadata of the resources downside here, and more importantly, there is the results. So for each policy, you're going to have the result, and we augmented the result with properties, adding those keys that refer to which policy was used in this audit. And yeah, and then there is like scope, which is some metadata of the policy, and the summary how it was before. Sorry, some metadata about the resource, and then the summary how it was before, saying that we have 10 policy which are failing. And then also, if you do with wide, you can see a better list table about which policies are which results policy results you have inside your cluster.
That's super nice. That's really nice. Okay, silly questions. So now we have moved from one way of using policy reports to another. That means now that
yes,
the previous ones need to be cleared.
The user can back up the previous one. You can see, I think, in the list down there, there is like this policy report namespace default. This was the old format where like it was just one policy report for the whole namespace. This can be cleared, or it can be saved somewhere else, or if they are important for auditing purposes. And after that, we will just update those reports which are resource based every time we get new result if something changed in the cluster. And yeah, and also we are working on the UI as well, and trying to like show this new format also in the UI.
On the UI now, we are talking about the downstream UI, which would be, yes. Well, we have two in that sense. We have the policy reporter UI, which does support that. No, does support the new format. It's just gonna suddenly, you're not gonna notice much difference. It's gonna report the same. And I suppose you were talking about the Rancher downstream UI, no?
Yes, I am talking about the Rancher downstream. Yeah.
Okay, so yeah, at some point it will get updated, and that's it. I think it's a good overview. Fox, do you have any questions?
Yeah, I wanted to point out that there was also some work done to run the audit scanner in parallel.
Oh yes, I forgot about that. Yeah, so there was the 50% of speed increase, like of time increase, like not decrease actually. So before we were processing one resource and then one policy, and in a sequential way. So when a policy was slow, because maybe it was context aware, so it took more time to be audited, then it was kind of like blocking everything. And now we added like a semaphore, some sort of worker pool pattern where we actually spawn, I think it's 100, but also this one could be made configurable in the future, 100 parallel requests. And this is also possible because we are saving for each resource, we are saving just one report, and well, before we needed to wait everything to be finished to save the report. So we are faster in the sense that we do requests in parallel, and this speeds up like the things a little bit, especially when talking about clusters with a lot of resources, which was another feedback coming from users.
That's great. I mean, that's a super good improvement for the audit scanner. I think that's it, no, for the audit scanner. But that's not it for 1.11. We still have a lot of things. The next thing on the list would be the performance improvements on the host calls of policies. I
Yeah,
suppose,
I'm
Flavio?
going to take it. Yes, let me see if I can share my screen.
Yep, perfect.
Yeah. Okay. Do you also okay?
Yeah, we see the GitHub issue.
You're muted, Flavio.
Okay, thank you. I don't know
Yep.
why I turned out muted. Okay, so basically, again, this is feedback coming from the community. We have a community user that is running Kubewarden inside of really large clusters, and they reported that there was a difference in terms of evaluation time between policies that are making use of context aware information, so policies that are fetching data from the Kubernetes API server, and policies that are not making use of this sort of data. We looked into the issue, and it turned out that this was not just an issue with policies fetching information from Kubernetes. It was part of, let's say, a bigger problem. It was about policies that make use of host capabilities versus policies that do not make use of host capabilities. Fetching Kubernetes resources is just one of the host capabilities that we offer. And so these user was also making use of a policy written in using Rego. It was a gatekeeper policy that was just compiled to WebAssembly and run without any change on top of Kubewarden. So we set out on on an exploration, trying to figure out what was going on. So we basically were able to reproduce the issue. The user also noticed that the delay was directly proportional to the number of resources that were exchanged, that were fetched from the API server. So this policy was looking into namespaces, looking into the namespaces defined inside of the cluster. And the performance number were, staggering. If you had like 7 namespaces, 100 namespaces, everything was fine. But the production cluster that they were using was it had 3,000 and even more namespaces, and with this amount of data, the evaluation time of the policy was crumbling. It was, to be honest, it was not the evaluation time of the actual policy. It was, the latency introduced by the admission controller, which takes into account several factors. But it all boiled down to basically the way that host callbacks are handled, at least they were handled, and then there was something specific to Rego. So we have some load tests, and we use these load tests that are written using K6 to try to reproduce the issue, and we were able to reproduce the issue. And here you can see that there is some benchmark data. So you can see here that the average response time of a non-context aware policy is around 10 milliseconds, 11, okay? While with a gatekeeper policy that is absolutely doing nothing more than asking all the namespaces, and then is doing nothing with these namespaces. It's always accepting. It's just requesting the 3,000 namespaces. So the evaluation time, the average response time is way higher. We go up to 700 milliseconds. We also have some policies that take up to more than 1 second, which is not a big deal inside of Kubernetes, meaning that you have 10 seconds timeout to provide a response. But it's bad. It's bad because it slows down thing. All this latency introduced by the admission controller, it is slowing down other operations. And so
Question. This
yeah.
is on a local cluster, no? So local development cluster in a sense of
Yeah,
local
it
machine,
is.
small
Yes,
machine.
it is my laptop running just one policy server outside of Kubernetes, and fetching, this information from a cluster running inside of a virtual machine. So, of course, with a more beefy machine or with a bigger, replica size of a policy server, these numbers would be better because there would be less pressure applied to it. Also, K6 here is simulating 20 virtual users and is doing quite some intense load on the on the policy server. So this is a bit to an extreme, but this is good because it shows the worst case scenarios. The same policy rewritten with TinyGo, as you can see, it is almost similar numbers. It was 600 milliseconds, and here we are, 559, which is almost the same. So first thing it turned out that this is not just a problem with Rigo, it is also a problem with our WAPC based policies. So Fabrizio and I set on a journey to figure out what was going on, and we found a bottleneck with how host callbacks are handled. So that improved the performance of WAPC policies because Rigo policies handle the exchange of information in a different way, and this is relevant, and I will explain that. But that was the first fix that it was an easy one, and that made the performance pretty good. I'm going to show you, actually, I can show you some final results here. So the TinyGo, we had an 80% reduction, 80% improvement of performances thanks to, this patch. We went from, 500 something to 100 milliseconds. So that was pretty good, and I think it all came from this fix, because then the other fix was done inside of sorry, I'm now looking into. No, that was another fix that was common to all of them, but probably, it was common to all of them. And this was about, again, how we exchange information on some communication channels that we use on the host, on the policy server when the WebAssembly guest requests data. I don't want to dig too much into the details. But long story short, 1.11 is going to include all these fixes, and the final numbers look really promising. So we have seen that with TinyGo and Rust, any kind of WAPC-based policy, the improvement is 80%. With Rigo, the improvement is almost 27%. So it's less than that. There is still something that we can do with Rigo. We had a theory, Fabrizio and I, and we wanted to try it out. So we basically act a quick solution to verify our theory. And it turns out that this is something that is worth to be explored. So this is the performance coming from this quick POC, where we have all the patches I've shown before, and then we have one further optimization for gatekeeper policies. And the numbers then they fall down a lot, and they basically are the same as the one of WAPC policies. So this is pretty cool, and this is something that we will. It's not part of 1.11 because it's something that needs more work, but we're going to work on it during the next weeks, and this is definitely going to be part of 1.12. I also
looks
wanted.
great. The number basically brings the performance of Rigo to the level of WAPC policies, no? In a sense.
Yes, definitely, yes, which is good. Yeah. But then we were reflecting on something, this specific policy that we were looking into, I mean, the real one, not the one that we built for debugging purposes, that is always happy about something. It just wants 3,000 namespaces, doesn't do anything with them, is always happy. The real policy was basically, it was requesting all the namespaces defined inside of a cluster, and then it was looking for a namespace defined inside of the object that was being evaluated. So there is an admission request. That admission request has inside of it a Kubernetes resource that has one namespace that is being referenced, and the policy just wants to make sure that this namespace that is referenced actually exist. And so it's a bit it's not the best thing in the world, to ask for 3,000 namespaces just to figure out if one is missing, because the more information you move back and forth, the more time it takes, to CPU power, to compute all of that. And so I basically rewrote this policy with TinyGo, with WAPC, because we have basically two-way gatekeeper policies. They have only one way to get information. This is how gatekeeper has been designed. So you say, I'm interested about namespaces, and so gatekeeper will fetch all the namespaces defined inside of a cluster. If you're also interested into pods, it will fetch all the pods defined inside of all the namespaces of a cluster, and then it will use this information to call what is called an inventory, which is a dictionary built in a special way, and then it handles over all this information into the policy. And the bigger, the amount of data you have to send down to the policy, the more time it takes to build it and to serialize it, and then to load that into the WASM memory. It's not a matter of loading that into the memory. It's a matter of, the WASM code of Rigo then does its own deserialization inside of it. So it's quite time consuming. However, a better approach would be, to just make a single request. So you want to know if one namespace exists. So instead of asking for all the namespaces, we can use the other API that we expose for querying Kubernetes, which is, get me this resource with this name inside of this namespace and this type. And so in doing this operation, we can see that the average response time goes down to 27 milliseconds, which is, if we go up again and we look at how non-context-aware policies perform, it was around 11 milliseconds. So it's comparable, we go back to, it was 26 milliseconds. It's almost fair, So this is and this is way better than any kind of optimization we can do. Here we see it's 100 versus 27, And so the thing is, it would make more sense to rewrite some policies that, operate in this way, that need access to just some resources. The name of the resources, so you don't need to fetch all the possible pods, all the possible namespaces. Just go and look for the specific ones you're interested in. And so one solution to this problem would be to rewrite the policies to use Rust or Go, where we have this API available. The other solution that is something we've been discussing with this user from the community, and we would be delighted to know also the opinion of other community users. It would be to basically introduce to extend the Rigo language, the one that we support, to introduce a new built-in, as how they are called in Rigo, which are functions. And so basically introduce a new function like Kubewarden.get resource that then can be used to basically redo the same thing we're doing with this Go policy, but do that in Rigo. And looking into how usually Rigo policies are written, this, of course, requires you to rewrite a portion of the policy, but this portion is really small. And so it's not an invasive change, and it's probably way faster than rewriting the full policy from Rigo to Go. I mean, if you already have it, And so this is an opportunity that is mentioned down there. So if you have an opinion about that, this is issue 692 on the policy server repository. Please leave your comment over there, and we will take that into account.
Sounds great. So this change would be, instead of building, as you said, instead of building the knowledge amount of all the things in the cluster prior to executing the Rico policy would be just to get the resource, no?
Exactly,
Specifically, and that's it.
exactly. Yeah, but this is not coming with 1.12. This is something unless there is a lot of desire to have it. With 1.12, we instead have this dedicated issue, which is the Rigo serialization, which is the Rigo optimization, which is around serialization that I've shown before. So the numbers that I've shown before, the 82% improvement, it is coming from implementing these optimization. And this is yet another flame graph, which is showing, the current code, the one that is going to be inside of 111. And this is instead the code, the flame graph of the code with the key patch that we have, the one that we have to clean up. And as you can see, this is a huge improvement. There are many flames that disappear, So yeah.
This looks great. Okay. So then for this topic, do we have anything else on the performance improvement on host calls? I suppose not. I cannot think of anything, to be honest.
No.
Okay, then let's go with the next thing, which would be the new host capability for OCI manifest. I wonder, I suppose Jose worked on it.
Yeah. I hope
Okay.
you can see my screen already.
Yep, we can.
Yes.
So yeah, so I will quickly explain talk you about the new host capability, which is come from a user request. The user would like to have a policy that adds node affinity, considering the OCI, the platform that container image supports, which requires the access of the container image manifest. And that was not possible because our policy does not have access for any kind of external world information. So we need to add a new host capability, and we did that. So since 111, from 111 and later, policy authors can call it a function called get manifest in our Go and Rust SDKs, which reply with the OCI image manifest or the OCI index image manifest, and it can do whatever it wants to do with that information. This is an example with a blog post that will be released after the release of the 111 official release, which basically is asking for the manifest for the container image, a given container image string URI, and if their response is a OCI image manifest, it gets the annotations and do the same with the container image index manifest. One important note is that you need to handle all of these manifest types because the hierarchy is not mandatory to support both manifest, but the consumers should support both of the types to work properly. So if you decided to write a policy that use that function, that capability, you need to keep in mind that you need to handle both cases, okay? So basically, this function is just checking if the container image has the license annotation on it. It's pretty simple, and that will be available soon. And this blog post and the documentation, which is here, the reference documentation, will be released afterwards, after the 111 release. So if you want to do some kind of inspection of the OCI manifest, you can do that right using 111. It's basically that, nothing's more than that. I don't know if you have any questions. Pretty fast, I would say.
Yeah, but it's still great. So yeah, I mean, new host capabilities, this is always great. So it's context-aware things, no? So
Yeah.
one needs to define in the policy, I want to access this or that. No? Is that correct?
No,
Okay.
because you're not requesting nothing from Kubernetes, and it's just an internet request, let's say, for the external world. So, yeah.
That'd be good to know. Okay, I cannot think of any questions. I wondered if you guys have other questions for the benefit of those see in the recording later.
No, but you touched something that something that we might want to do in the future, which is it's a right now we have a really good security model when it comes to Kubernetes, because you have to say this policy can make requests to Kubernetes, and then you can specify what kind of resources it can get. We only do read requests. We do not do write requests. I don't think we will ever do write requests because this is out of our scope. But on the other end, we don't have any way to say, okay, this policy is allowed to make MOCI get manifest request. And this is something that, it's a bit of a pity. And maybe in the future, we should, find a way to do that as well. It's just, it's a matter of doing, extending what we have done with Kubernetes also with the other OCI, other host capabilities that we have.
Yeah, let's open an issue for that.
Yeah. Also, it will be clear for a user that uses the policy what the policy is doing. It acts also as a sort of documentation, and
yeah, that's true.
And also for other stuff like caching on the audit scanner, but that's another.
Oh yeah, that's another thing.
Because then we know if a policy will do something which is not idempotent in the request, and then not cache it. So, but that's another thing.
Yeah, that's true. Cool. Thank you.
Hey, but yeah, I mean, I'm happy that things, lay out together correctly one starts thinking about it, even if there's work still to be done. Okay, so more topics. Next topic is an announcement about KubeCon EU. So that's Paris. It happens next week. And we are delighted to say that we were selected for attending KubeCon as part of the CNCF Project Pavilion. So I'm just going to share the screen super fast. So the Project Pavilion from CNCF is about providing some venue for CNCF projects, and we are a CNCF project. And that means that... did I close the page? Yeah, that means that we will have a booth here in the plan of the Paris KubeCon. You can see here maybe a bit small project pavilion. And yeah, some of us would be there, and feel free to come and say hi. Maybe we are not going to be able to be there the whole week, and CNCF assigns booths per day and so on, and I think it's going to be Wednesday. Wednesday is the big day, to be honest. It's the long day, the one that has the cube crawl. So yeah, feel free to say hi and come around. And that's it for announcements of KubeCon. Okay, more topics. We have also the topic of the update to container resources policy. I wonder who's going to talk about it. I can go with it, or you say?
Okay, if you want. Yeah, that's cool, because that's another user from the community which updates a policy that we announced last community meeting, which is pretty cool. So we have that container resource policy, which forces some always mutate the policy if some of container resources are missing. And the user wants not to enforce and mutate the policy, but just checks if it's something there, and that's it. So let me show you what's
Meanwhile, you open so by container resources, you mean like memory and CPU one? Okay.
Yeah. So that's the original config. Can you see? Sorry.
Yes. Perfect.
Okay, cool. This is the original format, which you need to give the full request, the full limit, and max limit. And the policy always checks if the value is defined in the container resource match that requirement, like specifically the max limit. And if the limit is not set, the policy mutate and edit for you. But the user just want to check if the limits are set in the policy container, in the containers from the resources. So the community guy, which Tech Dufus, thanks, by the way, thank you for doing that, added a new value, a new configuration, which ignore values. If this value is true, you don't need to set the values, the full values and max limit value. and the policy just see if there is something there. If there is something there, the resource is approved, otherwise it rejected. So now we can do both ways, just check if there is something or enforce something if you want. So that's the contribution.
That's super nice. Yeah. Again, a shout out to Tech2Fus. The PR contains, as usual, no, unit tests and
Yeah.
end-to-end tests and all those things.
And then the
Nice.
policy is already released, so you can already use it. Yeah.
Yep. It's on Artifact Hub and so on. So yeah, you can just get the new version.
Yeah.
Okay. That's it for that topic, I suppose. Next topic would be code coverage improvements. If anybody
can
wants to
take
take
it.
it.
Yeah,
Yeah.
I can take it. Let me share my screen. All right. Okay, do you see it? Yeah.
Yes, I think we see the codecov.io page, no, for Kubewarden.
Yes. Basically, we are using CodeCov as an open source project. We are entitled to, to use it for free. So we started to, use it to track our code coverage metrics. And we have that was it was interesting because we have a mixed code base. So we have Go code, and doing that with Go proved to be pretty easy. Doing that with Rust, it was okay. I mean, we did some experimentation, but at the end of the day, everything is working fine. And so we said before that Audit Scanner went through some rewrite, and as a result of that, you have seen the code coverage also was definitely increased. All right. Now we have some areas that don't have code coverage that need to be investigated. To be honest, in some cases, this is code that is not really worth to be covered. Like, if something goes wrong, then print a debug message, warning message, because they have, so it's really small things like that. But we will go through it and figure out what is worth to be handled and what is not. Right now, what we are doing is to focus ourselves on, we have a goal of reaching at least 70. Reaching 100% is not something that we should be aiming for. There are also a lot of articles in the literature explaining why you should not aim for 100%. You should make sure that the relevant code paths are tested. So, but we set ourselves a goal to reach at least the 70%. And so the project where we are, working, we plan to work more in terms of priorities is the controller. And there is right now a lot of red stuff, and this is happening because we have also to fine tune the code coverage, because it is, for example, complaining about when you define CRDs, then there is a lot of code automatically generated by the Cube Builder, and it is complaining that some of this code is not covered. So this is an area that we plan to improve. Yeah.
Yeah, and yeah, just a quick thing that this doesn't give the full story about testing, because we also have end-to-end tests thanks to Martin, and so it would be nice one day to cross these two values and see what also we cover with the end-to-end tests, because the main problem was a lot of stuff. It's based on Kubernetes, so you can mock, but then you don't have the a test which is close to reality, and this is just for confidence, let's say, when we make changes in the CI without then having to hit the end-to-end tests, which are slow and costly. So this is another thing to take in consideration when talking why we are not reaching the 100%, because we are covered with end-to-end tests as well.
Yeah, that's a good point. Okay. Yeah, we're gonna keep working on that now, so that's great. And talking about things that we keep working on, the last topic for today, it's the 1.12. Yeah, I mean, we always work on what we call tech debt things, no? And we also have talked about changes to the performance improvement for RIGO policies. What do we have coming? Maybe we can have a look at the board, or maybe we can just talk about what we think that is incoming. Does anybody want to throw the first?
I can start by saying that we aim to publish 1.12 in a month from now, so around middle of April, all right? That's what we are aiming for. And the theme that we set for this next release is about performance and reliability. So these are the two main areas that we will be focusing on. Of course, then we also want to address technical debt, and as Victor said, you know, we want to carry some work in these areas on a sprint basis. On each sprint, we want to work on that. We also want to apply to CNCF incubation. And because of that, we have a series of small tasks that we have to accomplish. And instead of doing all of them at the same time, again, you know, slowly, you know, week by week, we plan to work on that. But main theme, as I said, is performance and reliability. Having said that, I don't know if you want to show something or just, you know,
I think it's a
everything is
good.
in the open, but yeah.
Yeah, I think it's a good overview, you know. I'm okay with that overview. As usual, we work in the open. I forgot to say that, no, in the beginning. We work in the open. The agenda of this meeting is in the open. Anybody can join, and the same for GitHub issues and follow-up work there. So if you're curious, just you can look as to satiate your curiosity. Of course, we work on what we have, and we prioritize our tasks and so on. So yeah, that's it.
Yeah. If you don't know, I mean, everything is on GitHub. If you go to the Kubewarden organization and you look into the project boards, you will find our project board, and in there you can see what we are working on as in terms of, you know, the sprint. You can see the priorities inside of our to-do column, and then there are a bunch of tabs inside of the project board, and there is one which is about milestone. And so you will see that there is the 1.12 milestone, and you can see how far we are into that.
Yep. Okay. So I think that with that we are complete for these office hours. Was a longish one, but quite filled with things. Maybe we have any other topic, any other last minute topic. Nobody can think of any. So I suppose that's it. As usual, many thanks for those in the call today. Many thanks for those watching this recorded later on. And we hope to see you in KubeCon, you in Paris. So with that said, many thanks and see you around.
See you. Have a great day. Bye-bye.
See ya. Bye bye.
Guys, bye bye.